Let's start with exercise 13.2 of chapter 13, and it's based on multiplication theorem of probability. So multiplication theorem of probability says that if we have two events E and F, then we have to find the combined probability of E and F. So that should be probability of E into probability of F when E has happened. And if we have to find the combined probability of three events, then it should be probability of first event multiplied by the probability of second when first has happened multiplied by the probability of third when both first and second has happened. So we will check this in this exercise 13.2 as well. Next topic of our concern is independent events. So two events E and F are said to be independent if the occurrence of F doesn't affect the occurrence of E, and this happens only when probability of E intersection F is equal to the product of their individual probabilities. And because we have already studied the mutually exclusive events, so let's just draw the difference between the independent and the mutually exclusive events. So in independent events, the probability of both the events can be zero or may not be zero. But in mutually exclusive events, the probability of the both the events is always zero because there is no common element between the two events. So it should be very clear that uh, the probability that this independent is defined in terms of probability of events, whereas mutually exclusive event is defined in terms of events or the subsets of the sample space. Because in mutually exclusive events, we will never get a common outcome. But independent events may have a common outcome. So independent and mutually exclusive are not the same. They do not have the same meaning. And let's just try to solve the question number one, where it said that A and B are independent. So if A and B are independent events, then probability of A intersection B should be equal to probability of A into probability of B. So probability of A intersection B should be equal to probability of A, that is 3 by 5, into probability of B 1 by 5. So our answer is 3 by 25. That is the answer for the question number one of exercise 13.2.